Good morning, my fellow scientists. It is Thursday, April 20th, 2017. I want to talk more about iron batteries. Yesterday we confirmed that iron plus hydrochloric acid does in fact make hydrogen. That is not a good feature for a battery. That is decidedly a bug, so we need to correct that. And the way that is corrected in the Edison cell is to go to an alkaline pH, so they use potassium hydroxide for the Edison cell. But we don't want to use the nickel electrode of the Edison cell. We want to use something cheaper and more accessible. So my thought was, let's use an iron oxide, iron magnetite electrode. Problem there, of course, is that iron oxide is not conductive, and it's hard to make a good electrode out of a non-conductive material. And I said I couldn't find anything in the literature that showed someone actually making a iron oxide magnetite electrode. But as usual, if you can't find it in the literature, it's not because it doesn't exist, it's because you just couldn't find it. I did find it, cited on the Wikipedia article for standard electrode potentials. Someone did find the potential associated with the iron oxide magnetite reaction, so that's a good sign. Someone measured it. I dug up that paper. Well done on the Wikipedia editor who linked to it. Thank you. That article is shown here, and the key values are this value, which suggests that the reaction does work over a range of pHs that includes pH 11. That's high enough to be alkaline and will definitely suffice to make a alkaline cell. Additionally, they showed this graph, which shows the voltage as a function of pH, and that goes way out past where I need to be and still shows a appropriate potential. Bottom line, yes, it can be done, but the caveat is the particles they used to do that reaction are really, really small. So they used a colloidal suspension of iron oxide and magnetite being stirred, and that's not convenient for my purposes. So instead, I'm going to suspend my iron magnetite and iron oxide in a conductive carbon electrode. That's a lot like a zinc carbon battery, where zinc is being oxidized and manganese oxide in a graphite paste is being reduced. My hope is that when we take iron oxide micro or nanoparticles and mix them into a graphite matrix, we can use that as the cathode, and then we can have an iron metal anode, and that will eventually become an iron hydroxide anode, just like in the Edison cell. And on the flip side, we're going to have reduction of magnetite to iron oxide. We can build one of those over the next few days. I'll walk through that process and then we'll test it. Now, when you get into something like this, there's no guarantees it's going to work, so fair warning to all you people following along at home. This is real science, and yeah, I have no idea how this is going to go. But if you're interested in that kind of thing, real science, unknowns, building batteries, I hope you'll tune in tomorrow here in the Allen Lab.